We're going to focus on finding missing angles in a right triangle using those trig ratios for this video. So we're going to start by setting up our problem the same way we would when we were finding missing side measures. It's just solving for our missing piece. It's going to be a little bit different. We're going to start by looking at our angle. In this case, instead of having an actual number there, we have our variable, so we know that's what we're solving for. When we write it out next to sine, cosine, or tangent, we'll have the variable x instead of it being on the right side. So looking at x, we have 15 and 24. 15 is the opposite side, and 24 is my hypotenuse. The trig ratio that uses opposite side and hypotenuse is sine. So when I write that out, I'm going to have the sine of x equals 15 over 24. In order to get x by itself, we have to do the opposite of sine. For our trig ratios, we also have the inverse of them. So we have sine inverse, we have cosine inverse, and we have tangent inverse. When we write that out, we're going to have a -1 in the little corner of sine. So that's going to look like sine inverse, and then in parentheses, 15 over 24. It's sort of like doing the square root or dividing when we want to undo multiplying. It's just the opposite operation. So we would type this right into Desmos. Looking at Desmos, looking at our functions keys again, next to sine, cosine, and tangent, we do see their inverse. So we have sine inverse, cosine inverse, and tangent inverse, and we'll be using that when we solve these problems. Once we do that and plug it in, we are rounding to the nearest tenth. And in this case, since we're finding a missing angle measure, our answer needs to have the degree symbol with it. Looking at number 2, we're going to do that same process. So we're going to start with our angle and figure out what our trig ratio is going to be. I'm using 8 and 11, so from angle x, 8 is my adjacent side and 11 is my hypotenuse. Adjacent and hypotenuse goes with cosine, so I write that out as the cosine of x equals 8 over 11. I need to undo cosine, so the opposite of cosine is cosine inverse. When I write that out, I have the cosine inverse of my ratio, so 8 over 11. When we type that into our calculator, we're going to round to the nearest tenth, and we find 43.3 degrees. Number 3, we're going to do the same way. So looking at x, we have 20 and we have 37. 20 is my opposite side. 37 is my adjacent side. So when I do this, I'm using the tangent, and I have the tangent of x equals 20 over 37. I'm going to undo tangent by using its inverse. So the inverse of tangent, and then in parentheses, my trig ratio of 20 over 37. When I plug that in and I round, I find that x is 28.4 degrees. For number 4, again, from x, we're figuring out that trig ratio. In this case, I have my adjacent side and I have my hypotenuse, so we're going to use the cosine. When I solve for x, I'm using that inverse, and I find 38.5. For number 5, I'm looking at angle x. To use 40 and 41, I'm using my opposite side over my hypotenuse. Opposite over hypotenuse is sine, so the sine of x equals 40 over 41. When I solve for x, I'm using the inverse of sine, and I'm finding that x is 77.3 degrees. Number 6, that same way, we're going to start with x. 7 and 5 are my opposite over my adjacent, so when we write that out, we're using the tangent. Again, to solve for x, we're using the inverse of tangent, and we can find what x equals. 11, 12, 13, and 14 are done the same way, so I'll walk you through setting it up and then just show you that answer. When we look at x for number 11, 14 is my adjacent side, 22 is my hypotenuse. Adjacent over hypotenuse is cosine, so when I do that. That's how I'm writing out that problem. To solve, we're doing the inverse, and we find x. For number 12, looking at angle x, 25 is my opposite side, 78 is my adjacent side. So that's going to be a tangent problem. I have tangent of x equals 25 over 78, and I'm going to use that inverse of tangent to solve. For 13, looking at x, 31 is my adjacent side, 36 is my hypotenuse. Adjacent and hypotenuse go with cosine. When I solve, I'm using the inverse. 14, we are looking at x. 10 is my opposite side, 19 is my hypotenuse. That means I'm going to use sine. I'll have the sine of x equals 10 over 19. And solving for x, I'm going to use that inverse. We're going to look at a slightly more complicated problem for number 16. It's a little more complicated just because we have two triangles within one, so we have to make sure we're using everything the right way. For number 16, we're trying to find the measure of angle W, so I've marked that with Y. I'm trying to find that. If I look at the triangle that contains angle W, I don't have enough information right now to set up a trig ratio. All I have is 22. So I'm either going to need a hypotenuse side or I'm going to need my opposite side in order to set that up. If I look, the other triangle that they gave me with this picture, I do have enough information to set up a ratio. I have my angle measure and I have the side of 15, and I can use both of those setting up a trig ratio to find what xz is, what I've labeled as x, in order to then find my angle y. When I do that, I'm going to start with my angle, so 25. I have 15 as my opposite side, and I have x, the side I'm trying to find, as my hypotenuse. So setting this up, I'm actually using the finding missing side measures in order to answer this question about a missing angle measure. Remember, when we're setting this up, it's the sine of 25 equals 15 over x. To solve for x, we're multiplying both sides by x, and then we're going to divide by the sine of 25. So typing that into my calculator, I would do 15 over the sine of 25 and get that side length is 35.5. Again, we had to do this in order to find this missing side, so then we could find what the measure of angle W was. Now that I know that side, I can set up my other trig ratio. So we have, looking at that angle, x is my opposite side and 22 is my adjacent side. Opposite and adjacent, I'm using tangent. So I would say that the tangent of y, again, I labeled it as y, you can label it as anything else, is going to be 35.5 over 22. To get y by itself, to solve for that missing angle, we are going to do the inverse of tangent, and we're going to find that that angle is going to be 58.2 degrees. Our last example is a word problem, so we're going to look at the word problem and setting up a picture with it. We're talking about flying a kite, and we're talking about the string and the distance from the ground. When we set this up, it's important to draw a picture in order to help us figure out where all of our numbers go. Our kite string is 275 feet, so that's my hypotenuse of my triangle. 150 feet is the distance from the ground to my kite, and we're trying to find the angle that the string and the ground make. So I've marked it with x here. When we set up our trig ratio, we are going to have 150 and 275. From angle x, 150 is my opposite side, 275 is my hypotenuse. Opposite over hypotenuse is sine, so I have the sine of x equals 150 over 275. When I solve for x, I am going to use the inverse. And again, if we're finding a missing angle measure, we need to have our final answer have that degree symbol. So setting it up the same way, but this time we are using our inverse of the ratios, so sine inverse, cosine inverse, and tangent inverse. And we're doing that when we're finding missing angles in our right triangles using trigonometry.